Well, welcome everyone. I think we can start. Welcome to this last seminar for this season. Don't be too sad. Next year we'll come back. It's my pleasure to have and to introduce tonight three speakers. One of them is a colleague, but so I start with the first one. Mike Kestemont, who is assistant professor at the University of Antwerp in the literature department. Francesco Mambrini, who is working here at the German Archaeological Institut, where he is a researcher, and Marco Passarotti, also a researcher from the Cattolica University of Milan. And I will just hand it over to you. Deep learning and computational authorship attribution for ancient Greek texts.
Hi everybody, and welcome to this last digital classics seminar. What we are going to present in the next 45 minutes or so is a series of experiments with authorship attribution and new techniques, new and old methods for performing authorship attribution on a corpus of ancient Greek texts. And the corpus of the ancient Greek texts that we're going to use is the corpus of the Attic Orators. In case you don't know anything about what authorship attribution is, what deep learning is, don't worry. You will learn everything explained in full by more competent co-authors than myself. But let's first start with a few words about the corpus that we were going to perform experiments with and the problems that this corpus just raised for philologists and historians. This corpus, the Attic Orators, project us back to what was considered in antiquity the golden age of oratory, of public speeches. And of course, it sets us back to Athens in the 5th and 4th century BCE. Why was that considered the golden age for the art of public speech? Well, there are many reasons, of course. We can just point a couple of them. And first of all, when one talks about Athens in the 5th century, the first thing that comes to his mind is democracy. And the democratic regime of the city-state of Athens just needed a lot of administration where the art of performing effective public speech and persuade people was vital, basically. And not only that, not only because Athens lived with assemblies that voted laws and these laws had to be passed, or had many tribunals that discussed cases and ceremonies, but also because in the cultural life of Athens, this problem of the truth and knowledge and this problem of how, what the relation between persuasion of the authors and truth was extremely debated by intellectuals at that time. So it was the golden age of Greek oratory, and still today it's still quite popular for that. This is a preamble of the first draft of the European Constitution that, well, alas, sank, but it quoted what is probably considered the most famous public speech that our sources reported, the funeral orations by Pericles that is reported by Thucydides in book 2. So what do we mean by oratory? Well, in Athens, public speeches were extremely important in at least 3 different contexts. Court, right? Because people had to make the cases in court for basically the same reasons that we also make cases in tribunals and courts. So there was forensic oratory, how to persuade a jury to vote for you in criminal or public trial, in parliament, right, in the assemblies, because when laws had to pass, or in ceremonies like the funerals of the dead soldiers that I mentioned briefly before. Well, those public speeches by speakers were, at first at least, meant to be just performed to an audience and then forgotten. They had the effect that they wanted the orators to have. So a law is passed, a case is adjudicated to a person over the other, and then they were forgotten. But at one point, those speeches started circulating in written form, so that we would see that for the texts that are preserved today, or to designate the authors of those texts, the word orators is not quite the right definition, because many of those that we called the Attic orators didn't actually go on, or did only seldom go out in public and perform the text that they had written. Most of them were, we would say, probably ghostwriters or hired professional speech writers. For example, in court, Attic law, in most cases, demanded the person involved into the case to go on and make their own cases. Even in criminal trials, if your brother was killed, you had to make their own cases, go to court and make the prosecution and persuade the jury to condemn the killer. But nothing prevented you to go to the market and hire somebody to write a speech for you. Then you memorize the text, and you go on to the court and deliver the speech that somebody has prepared for you. In most cases, those hired the speeches that were made by these hired speech writers are most of the speeches that still survive to our days. So to our days, the speeches that we still can read are the product of a process of canonization where 10 names, 10 authors were selected already in antiquity. It's debated when, but we can discuss that later if you want. And those 10 names are those that are listed over here. So these are the authors and the speeches that we selected for our experiments. You can see that the distribution is very uneven. Some of them, like for example, the orator, Demosthenes, has got a lot of speeches. And those little stars that you see over there mark the cases where already in the antiquity people began to suspect that something wasn't wrong. So that some books were circulating, some speeches were circulating attributed to those people, but those attributions were suspected. We know, for example, for a fact that even if only right now 35 speeches of Lysias are normally printed in the edition of Lysias, so you count the speeches that are there in the editions, 35 of Lysias. In the antiquity, in the Roman times, there were like more than 400 speeches circulating. But some critics just went through them and said, well, okay, only 200 of them look authentic. The others, suspected. And so, okay, these are the two big names that, as you saw from the numbers, stand out. And Demosthenes and Lysias, the classic authors in the oratory. So why is this corpus interesting for us? We will go back on problems of authenticity in Lysias and Demosthenes later on, so that I can just go into a little more details. So why is this corpus interesting for us? Well, it's quite a large corpus for ancient texts. It's more than 600,000 words. As you saw from the chronology, it's kind of homogeneous in terms of chronology. It's the life of those authors span from the 5th century. So the Florwit, let's say, of the authors spans from the last quarter of the 5th century to the end of the 4th century. And in genre, it's homogeneous somehow because they all deal with public speeches in court, assemblies, or ceremonies, and it's kind of homogeneous also in terms of language. It's all Attic. It's all written in Attic Greek. It's a product of different personalities. All 10 authors have different biography, different interests, and a different political personality. But it also shows a lot of interesting problems of authorship. Some of them are also products of genre, because it's a different thing if you are addressing a people gathered for a festival or a court where your life or death is the matter of debate or a proposition of a law. And there is also the problem that, as I mentioned before, some of them were written for a specific target, for specific patrons that hired a speechwriter to. So it's one thing if you are written something for an illiterate peasant to plead his case on inheritance or a dispute on the water on his border, or if you've written a capital case for an important politician who was accused of murder, for example. There was a variation in these speeches, but is this variation the product of a different authorship, or is the product of the different target? These are interesting questions that are raised in our corpus. So just to give you a very short overview. Right now, let's talk about the methodology that we applied to investigate this corpus. And I leave the word to my colleague Mike to do this.
Hi, everyone. Good evening. The talk today is about authorship attribution. And authorship attribution is a big thing in something that we call stylometry. And stylometry is the quantitative study of writing style, computational stilistics, you could say. So what we study in stylometry is how a text is written and not what it is about. So we study style and not content. That's an important distinction. I'll come back to that later. And the idea there, the general idea, is that by measuring quantitative traits in the way somebody produces text, that allows us to differentiate between different authors, even to this extent that we can attribute anonymous texts to known authors. So what we basically assume there is that all authors have a unique fingerprint. Just as we have a unique genome, that we also have this unique stylome, it's sometimes called. That's of course sort of a controversial claim. That's not something that you can prove. But there's a lot of empirical research that has shown that we can actually do interesting things with texts. So what we're basically looking for is the stylistic DNA of authors. It's kind of a young paradigm, and especially the field of authorship attribution is often said to have started somewhere in the 60s with the work of Mosteller and Wallace, two American statisticians who were working on the Federalist Papers. You might have heard about that case study. It was a series of pseudonymously published papers that were advocating the ratification of the Constitution of the United States. So Mosteller and Wallace were statisticians, and that was pretty new still back at the time, that they approached authorship from a statistical perspective. So that was one innovation that you could attribute to these people. Another approach that they very much pioneered, you could say, is the use of function words in authorship attribution. I'll say something more about that now. So what are function words? It's these very small words in a language that don't have a real meaning, you could say. They primarily have a grammatical function. So you can think of articles like the, it, a in English, prepositions, even pronouns perhaps. So words that don't have a clear semantics, you could say. So they're only there to function, to offer a certain function in the language. Now, Mosteller and Wallace, they proposed to use these function words in authorship attribution. And it was actually pretty different from the way people had done authorship attribution traditionally in the 18th and 19th century, because authorship is of course something that has been studied for centuries already. Now, how would people have worked in the past if they were confronted with an anonymous text and they thought that perhaps it might have been written by some other author whose name we do know? So first of all, it was rarely quantitative, so it's perhaps a bit of a caricature to call it guesswork, but it wasn't very objective often. But what they would do was they would take the works of a known author, they would read the works as a reader, as a human reader, and they would keep a little checklist of all the things that struck them as a reader. So, hey, this is very rare. Okay, so this noun is a noun that isn't often used. And they would keep a checklist. And then they would take the anonymous text, they would use the checklist, and they would see whether one of these very conspicuous features was also present in the anonymous text. And if there were enough of these features present, they would attribute that anonymous text to the known author. So traditionally, people focused on things that strike you as a human reader, whereas Mosteller and Wallace, they kind of pioneered the approach to say, okay, let's go for the inconspicuous features in a text. And that's exactly what function words are, you can say. Because when you read a literary text, those are probably exactly the words that you don't pay attention to. So, function words. They have many advantages if you think about them in stylometric terms. So first of all, function words are very frequent in texts, and that makes them very relevant from a statistical perspective, because you have many observations. Also, what is interesting is that all authors writing in the same era, like these Attic orators, they use the same set of function words. If you think about it, nowadays you can't really write an English text without using the word the, or of, or the. So it's these variables, authors have to use them, which is very interesting. They occur in all texts, so it's that's very valuable if you start comparing texts. Also, what is interesting about function words is that they're not very sensitive to the content of a text. So the topic of a text doesn't really have an influence, you would think, on the frequency of the or of, for instance. Now, there's one really, really nice feature about these function words that I would like to show to you. And we're going to do a little test. On the next slide, I will project a small sentence, and you have to count how often the character F occurs in that text. So simply count in that sentence, how often do we see the letter F? And I'm going to give you 6 seconds for that. Okay, everyone ready? Yeah. How many Fs? 2, 3, 4, 5, 6, yeah. So what is interesting is that you can actually experimentally show is that people will skip the Fs in off. Why? Because when you're put under a lot of pressure, we don't seem to consciously process these function words. We take them for granted. So we really don't pay attention to them. And that's why it's often said that function words are used subconsciously. So we have to use them and we don't really pay attention to them. And also when we process text, we don't seem to pay a lot of attention to them. Second test, I'm going to show a text in a triangle. And you simply have to read it. And I will show it very, very quickly. Okay? Yeah, Paris in the spring. So it's interesting. Again, there what you can show is that people won't be able to process the duplication of the word the there. Again, because our mind processes it really quickly, doesn't pay attention to it. That's actually a very early research result in psycholinguistic experiments that it's very difficult to spot spelling errors when it comes to function words because we don't pay conscious attention to them, which is a very nice feature. Now it's interesting, so we don't seem to pay attention to them. So you could think, hey, they're not really important in the language if we don't pay attention to them, right? You might know this passage. That's amazing, right? We can still read this. So what has happened? All the characters in the word have been randomly jumbled, except for the very first one and the very last one. And it's amazing that we can still easily read this, right? Even if it's not our native language, by the way. Now, and this is something that has been shown that part of why this is so easy is because the function words that are very short words, typically, they aren't messed up. And basically that helps us process such texts, has been shown by psycholinguists. So very interesting. Function words, we don't pay attention to them, but they really form the skeleton of a language. Now, of course, we're talking to an audience of classicists here, and the first thing these people always ask after talks, they say, hey Mike, that's very interesting, these function words. But for instance, in Latin, a lot of the grammatical information that we have isn't expressed as a single word. So in English, many of these grammatical morphemes, you could say, are realized as individual words. But in more highly inflected languages like Greek or Latin, you will see that this information is actually stored inside words, in morphemes that are attached to other morphemes. And these grammatical morphemes are often called functors in psycholinguistic research. And I really like the name because it allows us to abstract over these morphemes that are realized as individual words and the morphemes that have been realized as part of another word. So people ask, so how do you deal with Latin? How do you deal with Greek? If you want to mine grammatical morphemes from such texts, how do you do that in authorship attribution? And there's this one very popular and naive solution to this problem, and that's called n-grams. I'm going to give you an example here. For instance, there you see the word bigrams in the second bullet point. And what we do is we take slices of length n, and we simply cut up a text like that. So instead of cutting up a text at the word level, we take these character slices. That's something that was originally used in language identification in the 90s, for instance. So for instance, if you have a text online and you have a system that might want to know whether this is English or German, people would use such features from text to look at or to decide what language a text is. What is interesting is that it has been shown in the past decade that these n-grams are probably the best feature that you can use in authorship attribution. Because what is interesting is that these n-grams can be sensitive to morphemic information. So for instance, the S there at the end of a word, you could say that implicitly there you are recognizing the plural morpheme. So that's very interesting because it's also a very cheap approach. So you don't need a tokenizer or a stemmer or a part speech tagger. You simply cut up the text in these character slices. And that's very interesting. A very recent study that actually showed that these morphemic n-grams are also the most useful n-grams in authorship attribution. So for instance, punctuation is one of the best style markers, has been shown for modern text. So whether you use like a lot of commas or a lot of dots, that's really interesting. Of course, we don't have punctuation for pre-modern authors. It's kind of sad. That's something that we can't use. These are n-grams. And just to give you an idea of what this would look like for this Greek data, this is a list of, or a partial list of the n-grams that we will use in our corpus. So we have all these particles like car, ou, prepositions like pro. And you see that these are often grammatical morphemes. Also note, we will be using character 4-grams, tetragrams, and that actually allows n-grams to cross word boundaries, as you can see in some examples. So this gives you an idea of the kind of features that we will be extracting from text. So authorship attribution, really great field. A lot of advances have been made in the past 20 years. Still many challenges. So one of the challenges is that we have very few reliable data sets on which we can test techniques. It's often very difficult to come up with a good corpus, for instance, because of privacy issues. People don't like to share their data. Also, one of the big problems that we have nowadays is cross-genre authorship attribution. That's very difficult. So if you have seen one author's style in a novel, it's kind of easy to recognize that style in another novel. But if that author wrote a theater play, it's going to be very difficult to recognize the same style. That's a problem of cross-genre authorship attribution. What is very interesting there is that stylometry is often presented with the selling point of research into suicide notes. So in the case of a suspect death and the murderer faked a suicide note, we should be able to use, people say, stylometry to verify the authorship of the suicide note. Now, of course, a suicide note is a very specific genre, and by default, you could say people only produce one suicide letter. So it's very difficult to do cross-genre authorship attribution there. Kind of a morbid example, but I think it's very important because it's often used as a selling point, whereas it shouldn't. Document length, also very, very difficult. So the shorter a document, of course, the more difficult it becomes to reliably attribute it to an author. And one of the continuing challenges, you can say, in the field is that we are trying to separate content from style. Okay, so these function words are very good because they are relatively insensitive to the topic of text, but they only work well if you have long documents, right? Because you want to look at these very subtle differences in frequencies. The problem is if you have to work with short text, you probably will want to mine some sort of information from content words too. Content words as opposed to function words. So for instance, whether somebody would use the word car or vehicle. So these are content words, but the choice for them, you could say, is a stylistic choice. Okay, so that's also a challenge. Artificial intelligence. Nowadays we use artificial intelligence to do authorship attribution. So basically what we do is we extract features from these documents, these character n-grams, or word frequencies or whatever, and then we feed them into an algorithm that basically works like a spam filter, you could say. So a spam filter is trained on examples of spam and non-spam, and then you have an algorithm decide to which category an email should belong. And of course, this is not something that people do manually. We have algorithms to do that. And nowadays you could say that this artificial intelligence is all around. The example of email filtering is very relevant to us. Also face recognition on Facebook is a good example, sometimes scarily accurate nowadays. And we even have autonomous cars hitting the road. Now, what these three applications have in mind is that they are a form of machine learning. Machine learning is a very important field in artificial intelligence. And what people believe is that learning is actually really central to human intelligence. So it isn't really strange that we know a lot. It's rather how we obtain that knowledge that is very interesting. How we learn to optimize our behavior in the light of previous experiences. Now, what these applications have in common is that you have some sort of algorithm that takes an input and then produces an output. It takes an image as input and then produces an identification like Sarah at the output. And of course, in machine learning, it's that little box there where the magic happens. Today we'll be talking about deep learning. Deep learning is a very specific paradigm, you could say, in nowadays computer science. And huge advances have been made there recently, for instance, in computer vision. Now, what does that box look like? In the case of deep learning, it looks like this. This is called a neural network. So what you see is that we have this information structure, you could say, with units that have been structured in subsequent layers, and the information flows through the network here from left to right. So here we have an input image, for instance, that comes in, and then we have an identification there at the end that comes out. So we have subsequent layers of information unit, and information flows like that through the network. So how is this different from machine learning in the past? And this is a bit of a caricature, but what people like to believe is that this is what we would do in the past, where we simply have an input and we immediately try to produce an output. And here with this deep learning or slow learning, you could say, we take our time and we introduce these intermediate layers, these hidden layers of information in between the input and the output. Now you might wonder, why is that a good idea? So why do we want these intermediate layers? Why is that a good thing? And that's something that's typically illustrated using an example from computer vision. So for instance, the application of face identification on Facebook or other social media. So what is very interesting is that these networks have different layers, and that these layers are sensitive to different kinds of information. So what we see in the beginning of the network, at these very low layers, these networks are sensitive to very primitive and raw features or edges, like these very sharp local contrasts, you could say. And it's only at subsequent layers in the network that this primitive information is being recombined into more complex features, such as an eye, an ear, and eventually an entire face. So what's very interesting is that this network is actually learning how to represent data in the best way. Again, an example of these low-level primitive features, you could say, and higher order features that are being detected, you could say. What is interesting is that neural networks nowadays can learn how to detect these patterns in images. And what used to be done in the past is people would try to make these filters themselves, really creating with pixels such filters that they thought might be interesting. That's a great advance since recently computers can learn to detect such features automatically. What is very interesting is that this is really analogous to how the human brain works. It has been shown, actually in all mammals, that when mammals inspect their environment, they will also first be sensitive to these very primitive shapes, and it's only at subsequent layers in the brain that we start recombining these into more complex and abstract patterns. And that's why this deep learning, deep because we have deep layers that are stacked on top of each other. It's also called representation learning. And that's actually a more objective name, you could say, because deep learning is kind of a hipster term in artificial intelligence nowadays. But what these networks are really learning is learning how to best represent data. What is interesting is that these networks, to some extent, can learn out of themselves, so they can do so autonomously. And there's a really nice example that we wanted to share with you that is related to Google's cat paper. I don't know whether you've heard about it. So what they did was they created this really big neural network, and they simply fed it 10 million images from YouTube, random images. 10 million images, that's a lot of data, you could say, but there was no information associated with these images. So for instance, if they would show a picture of a lion, they wouldn't say this is a lion, or this is a cat, or this is a donkey. So what they did was they fed these images to the network, and then after 1 week of training, they would try to find out what these little balls in the network had learned, you could say. And then they try to visualize what these little balls had learned. These are some of the detectors that they came up with. So the one on the right here is, of course, quite striking. It had learned to recognize cats, which is kind of amazing because nobody ever told the network what a cat was, but simply because there are so many cats on YouTube, apparently, they thought it was interesting to reserve some space in memory for images that look like this. Of course, it didn't know the word cat. It couldn't name this as being a cat, but it had learned how to recognize these. Very interesting. So autonomous learning, also faces, human bodies, etc. So I'm going to try to give you an idea of how neural networks work, okay? And I hope that will work, and otherwise you have to tell me. So at the University of Antwerp, we have chancellor elections coming up, and we have 3 candidates, right? And every faculty, here at the bottom, gets to vote for these candidates. So each arrow represents the fact that one of these faculties can vote for one of the candidates. Now, of course, as we all know, not all faculties are equally important in a university. So, for instance, because some faculty might have more students. And that's why, in fact, these votes will be weighed, right? So if a very small faculty votes for a particular candidate, that won't be very important. And exactly this voting process is what we call a dense layer. It's like the most basic building block in a neural network. Now, what does deep learning do? Deep learning will add levels of representation. Because, of course, where does the faculty get the votes? Do they get one vote, or do they listen to their students, etc.? So what you could introduce is another layer here, another dense layer that is based on the votes, for instance, from the student union, the professors, or the departmental library. And then here, at the bottom here, we have all the students and professors who are actually voting, and then gradually these votes will be aggregated, you could say. What is interesting in this network too is that at different layers there will be different sensitivities, right? The student union will care about free beer, and librarians will care about free books, you could say. So that's kind of how it works, neural networks, okay? And so what is learning? Learning, you could say, is lobbying for a particular candidate. If you know, for instance, that an image should represent a cat, what you are trying to do is changing these weights in such a way that, for instance, the cat candidate number 3 will get the highest votes in the end. Now, of course, what we will do in our text now is we won't have students vote for a chancellor. We will have the words in a text vote for an author. Okay? I'll come back to that. So this is the neural architecture that we will be using. It's a very simple neural network. It only has 3 layers, which actually makes it a toy network. If you compare it to what people are doing in computer science nowadays, they train networks of 150 layers easily. So this is just messing around in their eyes, you could say. So I won't go into too much detail, but we use a neural network, and you kind of know how it works now. And what we did was we compared it to 2 other machine learning algorithms. The thing is, networks are very uncommon in stylometry nowadays. There are a couple of applications, but they're definitely not mainstream. And that might have to do with data size. So I myself too, I was pretty pessimistic about whether this would work for authorship attribution. Because normally, these algorithms, they look at 10 million images from YouTube. So they really need a lot of data to be able to function properly. Whereas, as I said, these data sets in authorship attribution, they're really tiny often. If you have a corpus with 200 authors, that's a very big authorship attribution corpus that you have. And the corpus of ethic orators isn't very large from that respect. So it's a large corpus from the point of view of classics. It's a tiny corpus from the point of view of computer science, you could say. So we will compare this neural network that we have to 2 very popular approaches to authorship attribution in the past, which is Burrows' delta. And Burrows' delta is a nearest neighbor algorithm. So it's a very simple algorithm. When it has a new text coming in, an anonymous text, it will simply look up the text that looks most like it, using a very standard algorithm. And it will say, okay, the green little ball there must have been written by the same author as the author of the red triangle. That's a Burrows' delta, you could say. And you will also use support vector machines, which is another learning architecture with a very fancy name. But basically what it is trying to do, if it has examples from the blue author and from the red author, it will try to find a margin between them that separates them. And then whenever we have a new text, we try to find out on which part of the margin the new text comes in. It's kind of a complex algorithm. People have called it the black magic in stylometry, but it's a very, very powerful authorship discriminator. So how do we represent text in our experiments? We basically create a matrix, an Excel spreadsheet, you could say. And every row here represents a text by a specific author, an Attic orator. And every column will represent one of these n-grams that we will extract from these texts. And basically what we will do is we fill this matrix with relative frequencies. Namely, how often does the first n-gram there occur in a particular document. Okay, so this is how we represent text. This is called a bag of words model because we simply count how often these things occur in a text. And we don't really care about where they occur or what their sequence is. So we treat the text as a bag of words and we simply count how many words we find in that bag. So we did an experiment where we tried to find out this neural network, how well can it do authorship attribution and how does that compare to the other algorithms that we have. So what we did was we took all these texts that we have from the Attic orators, but we removed all texts that were disputed, where people had voiced doubts in the past saying, okay, this is kind of fishy. So we excluded those. We took the certain texts, you could say, and we cut them up into little samples of 1,000 words. And that's kind of a challengingly limited document size. 1,000 words is actually a very short document size if you want to do reliable authorship attribution. But what makes it interesting is if you make the task hard, it becomes easier to see differences between different algorithms. One problem is that we have a huge class imbalance in the sense that, for instance, somebody like Demosthenes is highly represented in the corpus. And there's also authors like Isaias who are much less frequently represented in the corpus. So that's one problem that we will have to deal with. So how do we evaluate this? There's a little trick that people use in machine learning that is called leave one out experimentation. So how does that work? So we have this corpus of which we know the authorship. So what we do is we select one and we put it aside and we treat that we pretend that we've never seen it. What we do is we take our system, we train it on the remaining texts, and then we have it classify the held out text and we see whether it was correct or not. And we do this iteratively for all the texts that we have. And at the end we can take the average of all the attributions and then we kind of know how well this algorithm performs, how well it works. And we've evaluated this using a number of measures. So I won't explain the two others, but accuracy is the easiest one, you could say. So out of 100 attributions, how many attributions did the algorithm get right? We experimented with different features. So for instance, with these character n-grams, how long should these n-grams be? Should they be of length 4, of length 2? Should we include plain words, etc.? And a very important feature that we experimented with is the width of this column. So what we always do is we select the most common features from a corpus of text, but you can select the 200 most common features, you can select the 2,000 most common features, or even the 20,000 most common features, which would basically include every n-gram that you have in the corpus. So here are the results. We have delta, the SVM, the support vector machine, and our neural network. What is interesting to see is that if you only use 200 words, the SVM will actually be a very good attributor. Delta, which is a very, very simple algorithm, nevertheless gives very good performance. So here we include results for words, where we look at word frequencies, and also results for character tetragrams, where we look at the frequencies of these units that I showed on a slide before. What is interesting is that the neural network in the end gets the highest single score, but the difference isn't large, you could say. So for instance, the SVM also gives pretty decent results. What is very interesting is that if you include all features, this very, very large matrix as the input for your algorithm, you see that the neural network nevertheless continues to produce very high results, whereas the other two sink into oblivion. Especially there with the words, you can see that there's quite a dramatic drop in performance, whereas the neural algorithm seems to have a way to deal with these very, very large matrices very efficiently. So I was kind of surprised actually by this result because of this very limited size of the data set. I didn't think this would work, but apparently you can get these neural networks to perform at the same level as, for instance, a support vector machine, which is currently considered the state of the art in the field. So that's very interesting. And this I already said. What is very important in stylometry is visualization. So especially literary scholars, they like to obtain a visual representation of what their data looks like. And this is often done, for instance, using PCA or principal components analysis. Basically what we see here is a two-dimensional representation of this very big matrix that we have. And the idea is that a PCA, if two texts have a similar writing style, they will be plotted in a similar region in the plot, whereas they are completely different, they will be plotted on opposite sides. And this is a tool that is commonly used by digital humanists in literary studies. So here we have plotted such a matrix. What you can, for instance, see is that we have a lot of ISO samples there, and then here Demosthenes is dominating that part of the corner. And what you can, for instance, do then is these are all the non-disputed texts. What you can do then is add the disputed text to see what their position is in this stylistic space. PCA is an unsupervised technique, so it's not able to exploit the information that we actually have for the text of which we know the authorship. What is nice about these neural networks is that they're actually not a black box, you could say, but you can really use them to look at what the algorithm has learned. So you can pry open the black box and see which kind of stylistic knowledge that the model is actually using. So if we produce a similar representation for the neural network, you can see that it has obtained much better clustering than the PCA would do. In a way, this is normal because, of course, this neural network architecture has access to the class labels, so it knows how to cluster these authors. And that's why, of course, the PCA gives you a much fuzzier image. But here, of course, you could claim, okay, the network has a really good idea of how to separate different authors. We can add the disputed samples again. And this is where the interpretation starts, you could say. So we have now produced the result. We know that the result should be kind of reliable. And now we can produce these visualizations that might induce a certain serendipity. So now we start looking for things or happy accidents that we didn't expect, these unexpected discoveries. So just at first glance, what is interesting is that you see that a number of the disputed Demosthenes texts actually nicely cluster with the non-disputed texts. So there you could say, okay, here we have an argument to actually say these texts are authentic. We don't really have a reason to doubt their authenticity. On the other hand, we also have these two Demosthenes samples that cluster there in the bottom where something else must be going on. And apparently we also have this very tight sample cloud there in the middle where there doesn't really seem to be an answer. But what is interesting, again, there are a lot of Demosthenes samples that don't cluster with the other non-disputed Demosthenes samples. Okay, so this is where the reasoning starts, the negotiation, if you will, with the computer. So this is like a global visualization of the corpus, you could say. Of course, what is interesting is prying open the model and asking the algorithm, so okay, if you're trying to recognize Demosthenes, what is the kind of stuff that you look for? And that's something that you can ask the algorithm. And this is where you come in.
Well, as Mike said, now the interpretation part starts, and so we can start, if you know something about these authors, if you know something about those problems, to ask, why is that so? Why is it telling us something interesting to begin with? Yeah. So, as Mike said, we are opening the box and we are looking at the features that the network used to learn how, like for example, Isocrates orations look like, and he selected as a telling feature this tetragram, this sequence of words. If you know something about Greek words, you will probably recognize immediately that this is a conjunction, a subordinating conjunction that's used on consecutive clauses, like so that. And if you know something about Isocrates, you could be struck by the fact that Isocrates is an author that is particularly fond of very complicated hypotactical syntactical structures. So the fact that the network selected this sequence of n-gram as telling about Isocrates' authorship actually does make sense. Does tell us something about something that kind of resonates with our own idea of Isocrates' style, because it points to a certain feature to create subordinates that certainly looks interesting from a perspective of a reader of Isocrates. But as Mike said before, it's always very difficult to tell when a mark is that a network like ours is selecting is a mark of a specific genre or a mark of a specific author. And that's an interesting case. This is Isaeus, right? It's our network selected the sequence of alpha, delta, epsilon, lambda, which you might recognize as a component of the word adelphos in Greek, right? Or forms of the word adelphos, brother, in Greek. Now, Isaeus was a logographer, a higher speech writer, whose work remains for us, only a portion of his work survives to our days, and a portion of these orations written by Isaeus that survives to our days relate to a specific type of court cases that are on inheritance disputes. And so they are exactly those texts where we expect the matter to be about, the subject to be about, the talk to be about brothers and family relations. So is this sequence of words telling us this is Isaeus, or this is something that relates to the specific topic Isaeus is particularly known today for, inheritance disputes? So this is an interesting feature, and we can say something. For Hyperides, it selected the sequence of n, which is most likely the preposition in, followed by a definite article, right? I didn't know about that. That's something that's interesting for me. I would certainly go back to the editions of Hyperides and look for this. Is particular fondness for n preposition for, I don't know, I might discover something interesting there. So, what about the disputed texts? This chart tries to cluster these disputed texts and attributes. Mike will correct me if I say something stupid about this technical interpretation of this visualization. But it assigns a probability to each of the fragments of the 1,000 word fragments of the disputed text. So those texts where critics or philologists advanced some doubts in various degrees about the authenticity. And so it attributes the probability that this section of a speech is of one of our 10 authors. And it builds, after it does that, it tries to build clusters. So what do we see here? You won't probably be able to read these clusters, but immediately, as soon as I look at that, there are a few striking things that jump actually to my eyes. The first one is that we got a pretty good cluster of oration. You won't be able to read it, but these are mostly Demosthenes, as we saw before in the visualization that Mike showed us before, of oration by Demosthenes which are attributed. Again, 1,000 word passages from the disputed oration of Demosthenes that are attributed to Demosthenes. One striking case, Demosthenes 58. You might not know that, but oh, by the way, it's there are 61. Well, let's call them speeches attributed to Demosthenes in our manuscripts, and most of them are arranged thematically speaking, except for the last ones, like this court case, like 58 or 59, that were put by the end because already in the antiquity people had doubts about them. Yet, apparently, from a stylistic point of view, at least a section of this Demosthenes 58 looks like Demosthenes to the network. And what is the main argument against this, the Demosthenic authorship of this oration? Well, it kind of boils down to one fact. The fact that in this oration, somebody, the speaker, attacks Demosthenes personally quite violently, and it says, well, that Demosthenes was supposed to, my side. So, and this was supposed to be kind of striking. Why is Demosthenes attacking himself? Well, it was anyway written for somebody else, so why not? Why couldn't Demosthenes to make his cases? There are, even if not many, there are people who had just defended the traditional attribution to Demosthenes and said, well, he could have written this attack on himself if it served his cases, but its case. But anyway, let's once again highlight the important point from here. Stylistically speaking, at least one section, then there is another section that is assigned somewhere else, but at least one section goes over there. Another interesting thing, Demosthenes 7, the seventh oration on Alonnesus, its political speech, it was already suspected from antiquity of not being written by Demosthenes, and the striking thing is that the ancient authors know, we don't know exactly why, but they know an alternative author for this. And there are some historical facts that would make quite improbable that this oration was actually written by Demosthenes. And but there might be some confusion because we know that Demosthenes spoke about the same problem as this oration. But this oration is very unlikely, for historical reasons, that could be authentically by Demosthenes. And in fact, stylistically speaking, is assigned to somebody else. Now, we don't care about the assignment. We are not saying that this was Antiphon who wrote it, because this would be even more impossible than by Demosthenes. But it says that among all these 10 candidates, well, Demosthenes is not the one that looks most probable. So this is another striking fact. There are other interesting facts over there. Is genre an issue over there? There are a couple of considerations that one can make. First, both Lysias and Demosthenes have one funerary oration attributed to them, which is contested, and is highly disputed among philologists if both Lysias and Demosthenes wrote the oration, the funerary oration that is attributed to them. They don't cluster together. Well, in fact, Demosthenes 60, the funerary oration of Demosthenes, at least for one part, is clustered with Demosthenes. So it's likely, again, that this might be assigned to Demosthenes. That would at least speak to make a case for his authenticity. Demosthenes is also attributed a speech. Oh, yeah, okay. Let's again talk about, and Lysias is not highlighted over there, but again, Demosthenes, the interesting thing is that the funerary orations, however they are treated, of Lysias and Demosthenes, don't cluster together. So, and also the funerary oration of Lysias, at least one part of the funerary oration of Lysias is clustered with Lysias, with authentic Lysias. So this is again striking. They're not associated, they don't cluster together, these two funerary oration, and at least for one section are assigned to their traditional author, which is interesting. It's worth looking at this. We see that there are quite a few Demosthenic orations that are clustered with Isaeus. Interesting. Isaeus was the tradition knew the fact that Demosthenes studied with Isaeus, so it was his teacher of rhetoric. But it's not what's the point over there. So it's not some sort of early influence on the teacher, on the pupil. There, as we discussed before, as with the feature that's probably important in Isaeus, as the Isaeus mark, genre might be an issue, because if you look at those those orations that are attributed to Aesius, you can look that they come from the section of the Demosthenic corpus that treat with inheritance dispute. So, well, that's something that should be looked into and maybe adjusted in our experiment. But there might be more than to say. Probably we can discuss that in the question and answer section. We thank you very much for your attention, and we can look forward to continue this discussion in the future. Thank you very much.